Bismillahirrahmanirrahim. My name is Ms. Mehwish Haris and I am your maths teacher from Peshawar Model School. This is our 9th lecture. In this lecture we have to learn about the commutative and associative laws with respect to union and intersection and their verification. It is related to the exercise 1.1 that is on page number 13. Now get ready for this, boys. So our first law is commutative law with respect to union and intersections of set. Now in this case there are commutative law of union of set and commutative law of intersection of set. Commutative law of union state that A union B is equal to B union A, means left hand side is equal to right hand side. Whenever we have to prove, must clarify and we must have to prove that left hand side is equal to right hand side. So my dear student, commutative law of union of sets indicates that A union B is equal to B union A. Now come to the opposite of union, that is intersection. So it is commutative law of intersection of sets. In this situation there are only two sets, A and B, set A and set B, but the operation is different. We have to find here A intersection B is equal to B intersection A. We have to learn about commutative law with respect to union and intersection. The first law show that A union B is equal to B union A. In this place, in this law, you must have to change their order. Elements of set A are same, elements of set B are same in left hand side or right hand side, but you just change their order. So whenever we have to change their order, there is no effect on the answer. Therefore left hand side is equal to right hand side. Same as the case, A intersection B is equal to B intersection A. Now come to the second topic, that is associative law with respect to WRT, mean W stands for with, R stands for respect and T stands for to, with respect to union and intersection of set. In this law again we have to use two basic operations, that are union and intersection, but in this associative law we have to use three sets. In commutative law we have to use two sets, but in associative law we have to use here three sets, set A, set B and set C. And whenever we have to describe associative law of union, we put the sign of union. So how can we write these three sets together? A union bracket B union C is equal to, now we combine A union with B and C should be separated from the bracket. Now you have to see here A union bracket B union C means left hand side. Now we come to the right hand side, that is, now we have to combine A union B and C should be separated. So it's mean in this law there is one operation is held, that is union. Now come to the associative law of intersection. A intersection bracket B intersection C is equal to A intersection B intersection C. In associative law we have to use here three sets, set A, set B and set C, and one by one we have to apply the operation of union and intersection. In this law again the element of set A, set B and set C are not changed in left hand side and right hand side, but the orders are changed. First you have to see that A union bracket B union C. Now on right hand side we have to combine A union with B and then C should be separated. Now come to the third topic, that is distributive law of union over intersection of set. Means in this situation that you have to see here commutative law of union of set, associative law of union of set, commutative law of intersection of set, associative law of intersection of set. It is little bit difference because in one law you have to use two basic different operation. Means again there are three set in this law, but the operations are changed. Means we have to combine here union and intersection. Now let's see how can we write here A union bracket B intersection C. It's over left hand side. Now right hand side is we have to combine A union B. Now we put the sign of intersection. Again we use and take the help of bracket A union C. Now distributive property of intersection over union. In this law, first we have to write here intersection. That's why we put the sign of intersection first. In previous law we have to write here distributive law of union. That's why we put here the union sign first. So distributive property of intersection over union of set means A intersection bracket B union C. Now how can we make their right hand side? A intersection B bracket. Now we put the sign of union A bracket A intersection C. Now these are the laws, and now in exercise 1.1 page number 13 we have to put these law one by one in our question. Before starting this question, I will explain this law in detail. That's why it should be help you in solving the question. So question number 3. If A is equal to, if elements of set A is equal to 1, 3, 5, 7, 9, set B is equal to 0, 4, 8, 12, 16, 20 and C is equal to 0, 1, 2, 4. Now we have to verify these law. Our first question is A union B is equal to B union A. Now it's mean there are two sets. It is the commutative property with respect to union. Commutative property with respect to union. WRT means with respect to. Now before solving this question, there are two sides, left hand side and right hand side. We have to solve here left hand side first. Now let's see students, it is very simple question. You already know about how you can solve the operation of union. In union we have to combine the two sets together without any repetition. So for that's on left hand side it is written that A union B. A union B is equal to, first we put the elements of set A that are 1, 3, 5, 7, 9. Now we put here the sign of union. Now you have to put the value of the elements of set B that are 0, 4, 8, 12, 16, 20. Now union means we have to combine these two sets. How can we combine? In an ascending order. A union B is equal to, the smallest value is 0. Then we come to 1. So 2 is missing in both these two sets. Now which order should we come here? 3, 4, then 5, 7, 8, 9, 12, 16 and 20. It is the answer of left hand side. Now come to the right hand side, that is in which we have to change the order. In left hand side A is written first, in right hand side B is written first. So right hand side is equal to B union A. So the elements of set B are 0, 4, 8, 12, 16, 20. Union, and the elements of set A are 1, 3, 5, 7, 9. Now again which operation we have to apply here? We put here the operation of union. We have to combine B union A and write in an ascending order like 0, 1, 3, 4, 5, 7, 8, 9, 12, 16 and 20. Now you have to check these, either the left hand side is equal to right hand side or not. So the answer of left hand side is 0, 1, 3, 4, 5, 7, 8, 9, 12, 16 and 20. Same the answer of B union A. Hence it should be verified that left hand side is equal to right hand side. So A union B is equal to B union A. It is our first law. Now come to the next question. B intersection bracket C intersection A is equal to B intersection C intersection A. In this property, in this law, you have to use C here. There are three sets, set A, set B and set C, and we have to solve the operation that is intersection. And intersection means we have to take the common elements. First we take the left hand side, and that is B intersection bracket C intersection A. First we have to find the bracket C intersection A, so we have to take and put the elements of set C first. The elements of set C are 0, 1, 2, 4. Then we put here the sign of intersection. Now we apply here the elements of set A, that are 1, 3, 5, 7, 9. Now we have to take the common elements between C and A, that is only 1. So 1 is a common element. It means C intersection A is equal to 1. Now we have to combine this C intersection A with B and take intersection. So now B intersection bracket C intersection A. Now we put here the elements of set B, that are 0, 4, 8, 12, 16, 20. We put here the sign of intersection, and now we put the value or the elements of C intersection A, which is 1. So it's mean we have again take the intersection. In intersection we take here the common elements. There is no element is common in B and C intersection A. So our answer is of left hand side is empty set. Means how can we solve the left hand side? First we solve the bracket, that is C intersection A. We put here the answer of C intersection A is equal to 1. Now we have to combine C intersection A with B and apply here the operation of intersection. B intersection bracket C intersection A. We put here the elements of set B and the elements of C intersection A. In this situation there is no element is common among these two sets, so our answer is empty set. Now come to the right hand side, that is B bracket B intersection C intersection A. First we have to find B intersection C. B intersection C means we put the element of set B, that are 0, 4, 8, 12, 16 and 20 intersection C, and the elements of set C are 0, 1, 2, 4. Now two elements are common here, that are 0 and the second one is 4. So there are two elements which are common in B intersection C, it's 0 and 4. Now we have to combine B intersection C intersection A. So we put here the elements of B intersection C, that is 0, 4. Again we put here the sign of intersection, and then we put the elements of set A, that are 1, 3, 5, 7, 9. Again we have to find here that there is no single element is common between these two sets. So it's mean again our right hand side answer is empty. From 1 and 2 we have to see that left hand side is equal to right hand side, hence verified B intersection C intersection A is equal to B intersection C intersection A. Now question number 4, verify the following: x is equal to 2, 4, 6, 8, 10 and y is equal to -4, -3, -2, -1. These are the negative integers, and v is equal to 0, 4, 8. Now in this question you have to see here the first part, that is on page number 13, and it is the question number 4. In this question you have to see that it is the distributive property with respect to union over intersection. I have to say that it is distributive property because there are three terms and there are two different operations, that is union and intersection. Union is written first, that's why we have to see that distributive property with respect to union over intersection. Now again in this question there are two hand side, left hand side and right hand side. First we have to verify left hand side, x union bracket y intersection v. In this left hand side first we have to find Y intersection V. Y intersection V means we have to take intersection, and first we put the elements of set Y, that are -4, -3, -2, -1. Intersection elements of set V are 0, 4 and 8. Intersection, it's mean common. It is there is no element is common. Some students are confused to see that 4 is present in both set, but in set Y, elements of set Y, then 4 is with negative integers, and in V it is a positive integers. We cannot, it's not compulsory to put the plus sign everywhere, but 4 is a positive integers in set V, and in Y 4 is a negative integer. So it's mean there is no single element is common among Y intersection V. Now we have to find X union bracket Y intersection V. First we take the elements of set X, that are 2, 4, 6, 8 and 10. Now we put the operation union, and we have to put the elements of Y intersection V, which is empty set. So union means we have to combine these two sets together. So the left hand side is equal to X union bracket Y intersection V is equal to 2, 4, 6, 8, 10. Now come to the right hand side. In right hand side you have to see here the two bracket, X union Y intersection X union V. So in this right hand side, first we have to find X union Y and X union V. First of all, we have to put the element of set X, that are 2, 4, 6, 8, 10 union elements of set Y, -4, -3, -2, -1. Now we have to see that negative integers are smaller than the positive integers. So we have to start from the in order of ascending order. So we put here the negative integers first. So -4 is smallest among the all, -3 is greater than -4, -2 is greater than -3, -1 is greater than -2. Again the negative integers are complete. There is not 0 written in set X. That's why we have to put here 2, then 4, then 6, then 8, then 10. Now we have to find X union V. First we put the element of set X, that are 2, 4, 6, 8, 10 union elements of set V are 0, 4, 8. Now we have to combine these two sets together. So in this sets there is no negative integers, so we find the smallest number element, that are 0, 2, 4, 6, 8 and 10. So it is not the complete form of right hand side. These are just the answers of X union Y and X union V. Now we have to combine and take the intersection of these two sets. X union Y, elements of X union Y are -4, -3, -2, -1, 2, 4, 6, 8, 10. Intersection, elements of X union V are 0, 2, 4, 6, 8, 10. Now intersection means we have to take the common elements. So 2 is common amongst the both two sets, 4 is common, 6 is common, 8 is common and 10 is common. So from 1 and 2, left hand side is equal to right hand side. So our distributive law is verified. X union bracket Y intersection V is equal to X union Y intersection bracket X union V. Now my dear students, complete exercise 1, book 8, page number 13. Complete the parts of question number 3 that are part 2 and part 3, and in question number 4 you have to complete part 2. Thank you.